if you look down here, you need to copy this down. So if I were you, I would write quadrilateral, K-I-T-E, with segment K-I, congruent to K-E, and segment I-T, congruent to E-T. So this is what we know. But they're distinct, so that's why I'm having to put one mark of congruency on one pair of congruent consecutive sides, and then 2 marks of congruency on the other pair of congruent consecutive sides. Now in a quiz or a test, I may just give you a diagram like this and tell you, hey, this is a kite. So I would say quadrilateral A, B, C, D is a kite. Well, if I tell you that this is a kite, then you are allowed to apply the definition of a kite. And that's one thing that you need to have memorized, is that a kite is a quadrilateral with exactly 2 pairs of distinct consecutive sides. So what marks of congruency would you be able to add to this diagram with confidence by the definition of a kite? That's one pair of distinct congruent sides.
CD and DA.
And that's that. So you are allowed to add that by the definition of a kite. And so over here, I have listed off the things we're going to learn. I would write these 6 things. The first one, the definition, it tells us that there's 2 distinct pairs of congruent sides. Now you already have the definition written, but you need to know that this is one of the 6 things you must know. Okay? This is one of the 6 things that you must know. Okay, then we have that, don't bother looking over here. The next thing that we need to know is, how many diagonals are there in any quadrilateral? How many diagonals? We just got done talking about this. 2. One of them in kites will create 2 congruent triangles. I need you to draw that in this kite. So you should have one of your quadrilaterals that's labeled K-I-T-E. One of the diagonals when drawn in, will divide this kite into 2 congruent triangles. Only one of them will. I need you to draw that in. Then ask yourself, well, how do I know these 2 triangles are congruent? You need to come up with the theorem. Alright, so which diagonal did you draw in? Segment KT. Okay, so you're claiming that these 2 triangles are congruent? By what theorem? Side, side, side. Yes, these 2 triangles are congruent by side, side, side. So this is the second property or fact that you need to know about kites, that one diagonal will divide the kite into 2 congruent triangles by side, side, side. This is the second fact you need to know. From there, what does it really mean when we say triangles are congruent? What are we really saying when we say, hey, those 2 triangles are congruent? Okay, so it's the exact same size and shape, meaning the sides are the same length and the angles are the same measure, correct? Okay, so now can we add any new marks of congruency to this diagram? What can we add? We can say that, well, since these 2 triangles are congruent by side, 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 I know with confidence that this angle is congruent to that angle because of what theorem? After we proved triangles were congruent, we were able to say, hey, all of the other stuff was congruent as well because of this. It was a long acronym. CPCTC. CPCTC. The corresponding parts of congruent triangles are congruent. So I know that these 2 angles are congruent by CPCTC. I know these 2 angles are congruent because of CPCTC. And I know these 2 angles are congruent because of CPCTC. Well, this gives us a lot of information about the kite. So now, let's take our focus away from the 2 congruent triangles. Let's look back at the actual kite. What do we now see is true about all kites? One pair of opposite angles are congruent, because angle I is congruent to angle E. Because once we looked at them as as split up triangles, and we can say, oh yeah, those are congruent and corresponding. So yes, one pair of opposite angles are congruent. We cannot say that this pair of opposite angles are congruent, because we don't know if these two added up is going to equal to that added up. But what can we say is happening about the other pair of opposite angles? What's happening to these two angles right now? What's up? These are not consecutive angles. These are opposite angles. They are opposite one another. What's happening to them right now? They're being bisected. Okay? So those are the next two facts that you need to know. That one pair of opposite angles are congruent. You need to be able to identify which pair of opposite angles. And then the second thing is that the other pair of opposite angles are being bisected. Well, what are they being bisected by? It's the diagonal that creates the two congruent triangles. So this is the definition. This is the one diagonal that cut it into two congruent triangles by side, side, side. Then we used CPCTC to learn this information, that one pair of opposite angles are congruent, and then the other pair of opposite angles were being bisected by the diagonal that created those two congruent triangles. Now we have 4 of the 6 facts you need to know about kites. This is the 4th of the 6. Okay. From there, we need to start looking at the diagonals. So I'm going to go ahead and erase some of this stuff that we talked about. But we need to investigate, how are these diagonals related to one another? Well, we've only been talking about one. And that's the one diagonal that's connecting the non-congruent angles. The non-congruent opposite angle. That's the only one we've been talking about thus far. And we've gotten those 4 facts just from talking about one diagonal. So once you remember all of this, let's go ahead and talk about the other diagonal. So this is the diagonal that's connecting the two congruent opposite angles. First off, this diagonal that's in red ink that I have drawn, how is it splitting the whole kite? How is it splitting up the kite? 2 triangles. What kind of triangles are those? Are they congruent? They're definitely not congruent triangles, but what are both of those triangles? They're both isosceles, okay? They're both isosceles. So this triangle here, these are your congruent legs, and then this triangle here, those are congruent legs. So you can apply the base angle theorem, and you can investigate those angles. So it's just good to know that it's being broken up into 2 isosceles triangles. But the things that I need you to remember is, first, the diagonals will always be perpendicular. The diagonals will always be perpendicular. And we know that the diagonals are going to intersect at some point. I'm just going to call that point P. Okay? There's no significance to the letter P. I just decided to call this point of intersection point P. And I want us to turn our attention to these 2 triangles right here. This one, KPI, and this one, KPE. What do these 2 triangles have in common? What? They're both right triangles. We haven't proven that yet, but they are both right triangles. Yep.
They both share line KP.
They both share segment KP. So we know that KP is, that segment's congruent to segment KP by the reflexive property of congruence. Can we say that these 2 triangles are congruent, same size, same shape? By what theorem? We have this side, that was given to us by the definition of kite, way back when. We proved that those 2 angles were congruent, and then they share that side. So yes, those 2 triangles are congruent by side angle side. If that's the case, then what's true about segment IP and segment EP? They're congruent. Why? What theorem? We've used it a couple times today. What did we just get done with? Proving triangles are congruent, so immediately after that, what are we going to use? Nope. What are we immediately going to use after we prove triangles are congruent? It's the long acronym that involves congruent triangles. CPCTC. Right when you're done, and we've done this in the past month, that right when we were done proving triangles are congruent, we use CPCTC. That's what's going to happen every single time. After you're done proving triangles are congruent, you're going to use CPCTC to help you learn new information about the diagram. So you want to look for congruent triangles. Because if you find a pair of congruent triangles, then you know a bunch of other stuff that you didn't originally know. So we know that this angle here is congruent to that angle there, because those are corresponding parts. We know these two angles are congruent. We know these sides. I'm having to add a bunch of marks of congruency because there's a bunch of stuff going on in this diagram. So what can you say about diagonal IE? What is happening to diagonal IE? What is it called when something is broken up into two congruent parts? It's being bisected, okay? So, and also it's written right here. One diagonal is being bisected. So these are your last two facts. This is how the diagonals are interacting with one another. Diagonals are perpendicular, and one diagonal is being bisected. These are the 6 facts you need to know about kites. These are the 6 facts you need to know about kites. Make sure that you have all 6 of those marked down, and also that you know how to get there. How would you prove that those things are true? Now we haven't done much with this other diagram. And that's because I wanted to, after we learned everything, we're just going to walk through those 6 things one more time. So if you want to leave this completely blank, that's up to you. But we're going to walk through these 6 things one more time, and we're just going to talk about how you can identify them on a quiz or a test whenever you're dealing with kites. Okay? So here we go. First, the definition of kite tells you, as long as you know it's a kite, then you are more than able to place these marks of congruency. This definition says that the kite has 2 pairs, 2 distinct pairs of congruent consecutive sides. So boom, we can add that because of the definition. From there, split this thing up into 2 congruent triangles by side, side, side. That's adding this diagonal. From there, this is what gives us a lot of our information about the opposite angles. Because now that I see that these 2 triangles are congruent, then by CPCTC, because we always use that, CPCTC, immediately after proving triangles are congruent, I know that by CPCTC I can see all of these angles are congruent. And that's what gives me my next 2 facts, that one pair of opposite angles are congruent, these guys, and then the other pair of opposite angles are being bisected. And they're being bisected by that diagonal that creates those 2 triangles. So really all I've done, or all we've done, is added 1 segment, and we now have 4 of the properties you need to know about a kite. All we've done is added 1 segment to our diagram, and we can see 4 properties that you need to know about kites. From there, the last 2 have to deal with how are the diagonals relating to one another. So you're going to have to add in that other diagonal. I would erase these just so I can clearly connect them. So this is the second segment I'm adding to my diagram, and that's just the other diagonal. And we know that that one is being bisected, and the diagonals are perpendicular. This is what you need to know, the 6 things about kites.